And the third one is that so you cannot have these instance of, so you cannot for example, uh, list is here, it's not yet instantiated with a specific type, it is still t, right? So you cannot say list is of instance integer, because again this will get erased. So all the t's would get erased and it's of type object. So again, this is not uh, it's not possible to verify it at runtime. So type information gets lost. So again, you cannot do these kinds of uh,
CB
comparison.
sir,
Yes.
when you say that this T gets erased, so what does that mean?
Yes. So in the previous class, uh, we talked about this, right?
That means it gets replaced with the whatever I'm using.
No, no. So there is this type erasure that we talked about, right? So let's say you have this generic type class called my generic list, and it has this t. Whenever you are instantiating here, in this case you are using replacing it with string. But what happens at compile time is all these t's and string, everything else would get replaced with an object. The type erasure happens. So for
Yes.
example, in the case of add t of o, instead of t, it's object o, and it is returning an object again. So it erases everything, all the t's, and since it's of type string, the only thing that it will do is it will be careful, or it will typecast it when retrieving the elements. So get
So
of 0 is of type string, get of 1 is also of course of type string. So it will do the appropriate typecasting. So this happens in the background, and that's why you cannot in the restriction that I said, you cannot compare t using instance of. Does that help? Are there any other questions?
yes, sir.
Okay.
Sir, can you explain the third restriction again?
Yes. So you cannot, for example, so in this case, you are trying to check whether the instance of this list is an integer list. So that cannot happen.
Sir, why are we writing that pointed bracket t after started? What is the significance of that?
Okay, I may have to block all the triple ITDs too. Sorry, can you repeat that? What
Sir,
was the
why are
question?
we yes, sir, why are we writing that pointed bracket t after static before void? What is significance for that?
No, it is returning. This is the return type, right?
But sir, return type is void.
All right. Oh, this is a good question. So I didn't notice this.
Sir, and sir, even if return type we were using return type as t, then it wouldn't be in the pointed bracket, right? It should be just t.
Right, right. That's right. Yeah, it should be just T.
Sir, after that, can you explain, by using typecast, you mean that I am trying to convert the t's object into something else, and instead of I'm checking if this particular object of t is an instance of this particular class or its subclasses, like this.
Right, right. Okay, so
Okay.
okay, let me first get to this one. So this one, yeah, I'm not sure either. Okay, I haven't. I'm not sure of this particular usage. So it's either a typo or it's a usage that I'm not familiar with. So let me check this and then I'll get back to you again. Okay, for the second question that you had, yes. So yeah, you cannot explicitly typecast it to a particular type. So you cannot say, you cannot check whether T is of type integer or typecast it to an integer or employee or person or whatever. Because this particular type, it gets erased completely. So it will become an object, right? So yeah, that cannot happen.
Okay, sir.
Okay. So the next one, next restriction is, uh, yeah. So you cannot have a static field which has the type T. So again, you have this myGenerate class. It has a type parameter which is T, and you cannot have a static field which is of type T, because the idea of static fields is that now it's common to every instance, right? It's a class level variable and it's common to every instance of uh, the myGenerate class. So an example is given here. So let's say you have C1, C2, C3, which are instances of myGenerate class, and each one has a different data type. So C1 is of type integer, C2 is string, and C3 is double. Now, since field is supposed to be applicable or it's useful for all the instances, right? It's a class level variable. So it will be confusing to say what, it's wrong to say what the type of T is. So it cannot be integer, string, or double. So that's why you cannot have a class level variable which is of type T. You can definitely have individual, instance level variables. So if you remove static, this is okay. It still works. But you cannot have a static type variable here.
Excuse me, sir.
Right? Yes.
If in this case, if the T is an integer, then
Right.
the static field would be of the type integer. Then it is just a field, so all the objects can access field variable of any type, right? That would be C2 dot
No,
field.
no. Okay, so the issue here is, so okay, when you have this declaration, for example, my class integer, sorry, my generic class, and the type here you are specifying it as integer C1 and so on. What are these, the known part? So you are saying that T should be replaced with integer, right? So
Yes, sir.
all the T's would be integers. Now, in the second case, you are saying that all the T should be of type string, isn't it? So now if you take these two statements, now field is something that's common for
For both
all
C1,
the
C2, C3.
instances.
Yeah.
Yes.
Okay.
So that's an issue that comes up. So, yeah, that's why you cannot have static space, static of type T, of generic type. Okay. So
Sir,
the next restriction, yes.
sir, if we are defining fields of the T type, but sir, you said that after the compilation stage, the T is very removed from the code of the class. So
Right.
how can we define the fields of this T type if they are not static? Like private T field, just that. How can we define that? Because after compilation, T should be removed from this class code,
Hmm.
right?
Yeah, so
So
let's say
when
if this is
we
not static and it's just of type T, yeah, so at compilation time, it will just replace T with object, and whenever or wherever field is used, it will typecast it appropriately. So for example, you have used integer for T. So wherever you use field, it will typecast it as integer, and then rest of the code remains the same.
okay,
Okay, so the other restriction is on subtyping. So let's say you have an employee class and a manager class, and manager inherits from employee. So every manager is an employee, right? So that's what the interpretation is. And now you have a pair class, which takes a generic type T. So you have pair of T. So when you instantiate pair of T, you create two instances. One is of pair of employee, and another instance is you're passing in as manager. So you're instantiating the type as manager. So although manager is a subclass of employee, it doesn't mean that pair of employees has any relation with pair of manager. There's no relation between them. So they are simply two different instances. One instance has type employee and the other instance has type manager for T. So there is no other relation between them, even though manager and employee are related. So is this clear? Are there any questions? Okay, so let me move on. So the other restriction is you cannot create a array. So generic array meaning, so this is a generic type. So you cannot have a array of generic type. Again, this reason is the same. So this related to the type erasure, right? So if, sorry, was there a question? Okay. Yeah, so you cannot have an array of generic type. So if at all you want to do this, then it's you can create an array of object type and then typecast it if you need it into whatever type that you want.
Sir, I have a question on this.
Yes.
So you said we cannot declare a generic array, I mean, an object of any type inside my generic class with T, right? I mean, we can only pass them as parameters of type T.
No,
but,
you cannot have static fields. So this is not possible. But if you remove static, yeah, it's okay. You can have private T field.
Sir, but one restriction said that we cannot declare a variable of type T inside my generic class. I mean, I think it was
right. You cannot say new T. That's the first one. This one.
Okay, sir, but all right. I understand. Because it will get replaced by object anyway,
right.
And you cannot typecast it later.
Yes.
Okay. All right. Thank you.
Sir, am I audible?
Yes.
So, sir, what will be the use then if we can only define, like declare but not instantiate?
Declare but not instantiate. In which case?
Like, suppose I have to like create a variable of type T, an instance variable of type T. So I can only declare it. I cannot instantiate it, right?
This one, okay. So if it's not a static field, is it?
Yeah, it's not a static field.
So you say private T field.
Yeah.
No, you can, right? So T would automate. So when you say my generic class integer C1 equals new my generic class, all the T's would be now integers.
Okay. But then, like in that restriction where we said that field equal to new T would not be valid. So what do we do about that?
No, you can always. So this is the case where you want to instantiate or have some value for field.
Yeah.
Right. That's what you want. Okay.
Yes.
I mean, you can do it explicitly, right? You can always have a set field later on and then do it.
So in a setter, I can assign a value to this.
No.
Right?
So this is not. I mean, okay. So making an instance of new T is not possible in whatever method you take.
Okay, so I can do T my var equal to some variable where that variable we have taken as input.
Variable you have taken as input. Oh, so as input parameter. Okay, somewhere here as argument.
Yeah.
Yeah, you can assign. So, but this again should be of type T. So for example, let's say we take the same method. So public void do something, and you have T of T1 something like that. So then you can say T myvar equals T1.
Okay.
Okay, so then we move on to the next one. So this is the continuation of the previous one. So why generic arrays are not allowed, right? Okay. So there are two terms here which we discussed in last class. One is called covariant and the other one is the invariant. So do you remember these terms, covariant and invariant? So invariant means you cannot change it. So that's like the final value, right? It's a constant. So all the class instances should definitely stick to that condition. So it cannot be changed. Covariant means you can change it, but with a certain set of restrictions on it. So we have talked about covariant return type, right? When we are talking about this object clone. So in the object class, clone is declared as, so the signature for clone method is protected object clone. Right? The return type is object and the visibility modifier is protected. But whenever you override this clone method, you generally use a public modifier and the visibility modifier. And then the second change that you do is you return the class type in which you are overriding it. So let's say you have the car class, car is overriding clone, then the return type of clone should be car. So in this case, you are while you are overriding it, you are also changing the return type, right? So that's a covariant return type, or it's called a covariant return type because you can change the return type, but the restriction is that it should be one of the subtypes of the original return type. So the original return type is the object, so it should be one of the subtypes. So basically any class can be put in there as a return type. So that's what we mean by covariant, right? So covariant, it is variable, but the variable nature is restricted to certain cases. So that's the general meaning of covariant. Okay, so the same thing applies here as well. So you have so you have your object array, and you can do this. You can say object array equals new integer of 10. So on the right hand side, you are explicitly specifying the type as integer, but on the left hand side, you are keeping it general, which is of type object. So this is okay as long as the right hand side is again subtype of the left hand side. Right, so this is allowed in general arrays, which is the case here. But if you take a generic array, that means there's a generic class and you are trying to create an array out of it. In this case, it's an invariant, meaning you cannot assign a subclass type to a superclass type. So which is what is happening here. So you have an array on both the sides. But on the left hand side, you have the array to be of type object, and on the right hand side, you have the array to be of type integer. So although integer is a subclass of object, you cannot make this assignment in generic type arrays. But in regular arrays, you can do this.
Sir, could you explain again what's the difference between list and array list?
Yes. So list is a interface. Array list is a concrete implementation.
Okay, sir.
So generally the convention is it's good to use the interface or the more general type on the left hand side, and then but you can use the specific concrete implementation while instantiating it. So it's a new array list.
Sir, so what do we mean when we say generics? I mean, how do we know whether a particular object or class is generic or not?
So when you see these square brackets, it's a generic type.
Okay. Sorry.
Because you can have list of integer, list of string, double, and so on.
Okay, sir.
Okay.
What is the difference between list, simple list, and array list?
Did you say three lists? So if it's list and array list, I just mentioned, right? So list is an interface. Array list is a concrete implementation of that list interface. So you can extend list. Sorry, you can implement list and then provide concrete implementations. And array list is one such concrete implementation.
So how did we create an object of list if it's an interface? I mean,
So your last part of the sentence got cut.
yeah, so I was just asking that you cannot declare an object of interface, right? You just implement interfaces in other classes. So you're saying that list is an interface.
Right.
How have we declared a mylist object of type list if it's an interface?
No. So okay, list is a generic type. It's a generic class that takes a it's a class that takes a generic type. So in the definition of this interface, it was you can add the t here. It was supposed to be list square brackets t, and then you have a set of methods which are part of the list interface that have been declared but not defined. So now in the array list, you are simply extending. I mean, you are implementing this list interface and then providing the implementations for all the list methods.
Uh, so I mean, so here list you're saying is an interface. So I
Right.
mean, I didn't understand how we created an object with an interface. I mean, don't you implement that with classes and then you create an object with that? So
No. Okay. So what? Uh, so for example, if you replace object with integer, right? This sentence works. So it doesn't give any compilation error. So you are simply saying that there's a list, and that list, every element in that list should be an integer, and you are referencing that list using the interface. So it's very similar to your transporter car, right? So you can say transporter t equals new car.
okay, sorry. Yeah.
Yeah. So except that both are of they can take generic types.
Yes. Okay.
Okay. So the reason why this is not allowed is again it's related to the uh, type erasure. So for example, you have, okay, here it's a mix of regular array and the list, right? So let's say you just assume that this is possible. So you have an int list, uh, which is a regular array, and then you are saying that such type of list should be 5 in number, right? And now you are creating a string list, which is straightforward, and this is correct. The string list part is correct. You are adding a string. Now you are creating an object array. So, and you are assigning that int list to it. But the first, so int list, obviously it has 5 uh, elements, right? So the first element is a string list. So it is a list of lists, basically. So so the first element is a string list, but again there would be a problem here because whenever you do a get, it will result in a class cast exception, right? So because you are on one hand saying that it's an object type list, but the first element contains a list of strings. So at runtime, since we are erasing all the types, it doesn't know what type we are talking about, and there'll be issues. So you cannot do this strict type checking at compile time. Yeah. So the takeaway here is you cannot have these kinds of declarations, where on the left hand side you have more general type and the right hand side you have more one of the subtypes. This is for the generic types, right? But if it's a regular array, you can do so. Okay, so shall I move on? Okay. Let's. So let's say you are given this code on the left hand side. You have the public class main, and then you have the print method that has this parameter array list of type object, and you are iterating through every element in the array list and printing each element. So now you have created one list, which is an integer list. You added 1 and 2 to it. You created a string list. You added 2 strings to it, Bob and Paul. Now you want to print both the lists. So you simply said print I and print S. So in the print method, it's supposed to iterate, like I said, over each element and just print it, right? So now the question is this code correct or not, or will this code compile? So if we go through the code, right? So here list will get assigned to, in the first case, array list of integer, which is a problem, right? So on the left hand side you have an object. It's a generic list. It's a list that takes a generic type. And on the right hand side you have a specific type called integer, and integer is a subclass of a subtype of object. And according to one of the restrictions that we have seen, this is not possible. So that's why this code will result in a compilation error. Right? Is that clear? So so in theory, this should have been okay, because you are simply referencing this through the parent type, which is object, and you are assigning that to one of the subtypes, which is integer. So in order to resolve this, there is a mechanism to resolve this, and it's called the wildcard, right? And this is
Sir?
very similar to your this is very similar to your regular expression wildcard. Okay, now you can ask the question.
Okay, sir. So could you please repeat why it won't compile?
Because of the restriction that we just talked about here. So here on the left hand side you have the super type, or the generic super type, which is object, but on the right hand side you have the subtype of it. So if it is a generics, if the generics are involved, right, like which is the case here, so list is a generic type, meaning any type can go in here. So if generics are involved, this is not possible. So you cannot have you cannot create an instance where on the right hand side the type is a subtype of the left hand side. So integer is a subtype of object here.
Okay, sir.
So here it is happening. So yeah, that's why there's error. But there's a way to fix it, and that's what we'll be looking at here. Right, the wildcard. And the wildcard, like I said, it's very similar to your wildcard in regular expression. So which is one of the wildcards, right? Which is the question mark. So if you have a question mark, it means that any type can come in here. So in this case, in the first case, it's the integer. So wildcard would get replaced with integer, and then second case is the string. So the wildcard would get replaced with string. So in this case, it will work. But there are other variations of this wildcard as well, which we'll see in the next few slides. So the first variation is you can have the extends keyword. So this particular wildcard can extend car. So that means there is an upper bound, right? So every type that is getting passed here should definitely extend car or one of its subclasses. So in that sense, there is an upper bound now in terms of the type hierarchy. Right? There is also a version with the lower bound. So you can have a wildcard super integer. So that means any type that you pass in, integer should be the super class for it. Or any type that is super class of integer also. Right? So for example, you can have integer, number, object. So all these can pass in you can pass them as the type here, and wildcard would be okay with it. It can replace this wildcard symbol with any of these types.